In 1 year, a football field worth of trees takes the same amount of carbon dioxide produced driving from Vancouver to Brisbane, Australia 5 times. Clearly, trees play an important role to combat climate change. Dr. Matthew Mitchell is an environmental researcher at the University of British Columbia. During his postdoctoral position in Brisbane, Australia, he carried out research to find out how the distribution of trees affect the amount of carbon stored in cities.
So basically the question we're trying to answer is really, does the structure of the landscape in cities impact the carbon?
The study involved measuring the size of trees to estimate the amount of carbon each tree stores. He also had satellite imaging data that gave him information of how much carbon was stored per unit area in the city. The more carbon stored in trees, the less carbon dioxide in the air, contribute to climate change.
Kind of the key result is that the distribution of trees and forested areas across the city, whether they're in big patches of forest or small patches, or whether those patches of trees are close together with each other or really spread out, that can actually influence, or there's a relationship between that and how much carbon is stored in those trees. So that basically gives us a potential tool that we could actually manage, a lever we can pull in cities to actually increase the amount of carbon that's stored.
Dr. Matthew Mitchell took us to the University of British Columbia in Vancouver to show us how you can determine the amount of carbon stored in a tree. We wondered, did he have any issues with getting permission from people to work in their backyards?
So the only issue is actually trying to find when people are home. So before going in, of course, we have to get permission from all of the landowners, and often people aren't home during the day. And so that was the hardest part, is actually finding when they're home. We'd leave pamphlets in their mailbox, but often they wouldn't respond to those. So that was the hardest. But when we actually talked to people, I'd say 95% of the time, people were extremely welcoming.
So we just go up to the tree, we basically just wrap this as smoothly and as kind of evenly as possible. And so this tree has a diameter of just over 65.5 centimeters. And some of them also use height. So if you were measuring height, we use this, what's called a clinometer, which measures an angle. So you basically, once you're far enough away from the tree, you measure to the top of the tree, and then you use that angle and distance and basically trigonometry. So right now we're at 30 meters from the tree. So we'll take a measurement to the top of the tree, which is 51 degrees. This tree is over 30 meters tall.
Our last question for him was about how the general public can benefit from this study.
Hopefully, the study will help to inform urban planners and managers that it's not just about planting more trees or adding trees to cities, that they can actually impact how much carbon is stored in a city based on how they design new neighborhoods or how they manage the city that's already there, where they restore forested habitats, that sort of thing. So, and that being able to do that and being able to increase the carbon storage in cities hopefully will help reduce carbon dioxide in the atmosphere and reduce the impacts of climate change.
Having trees and vegetation clustered together increases carbon storage in cities. Dr. Matthew Mitchell hopes his research will be implemented in city planning policies to increase carbon storage in cities and reduce climate change in the future.